The study of color is a scientific study which includes physics and anatomy and physiology and psychology. But it is, or rather should be, also a philosophical study because it addresses a fundamental problem in knowledge, namely, how do surfaces and objects maintain their identity in spite of the widely differing contexts in which we view them? For example, different viewing angles, different distances, different lighting conditions. And color vision is an excellent example of how the brain stabilizes the world to obtain constant knowledge of it. For example, if you were to go to a park on a cloudy day at noon or on a sunny day, or if you were to go there at dawn or at dusk, the leaves will always be perceived as green. But if you were to measure the amount of long wave or middle wave or short wave light reflected from these green leaves in these different conditions, you would find huge variations. So the brain somehow is able to discount these changes in the illuminant reflected from the green surface alone and assign a constant color to it. To study how the brain is able to do that, we must forget about, or rather not concentrate on traditional theories of color vision, such as the trichromatic theory or the opponent's color theory. These are theories of vision, really, not theories of color vision specifically. They include color, but are not specific to it. We have to use a different approach. And one approach, which I discuss in this lecture, is that of ratio-taking processes undertaken by the brain, by which I mean that when the brain looks to surface, it takes the ratio of long, middle, and shortwave light reflected from that surface and long, middle, and shortwave light reflected from surrounding surfaces. For example, if you look at this green surface of this multicolored display, when it's reflecting a certain amount of middle wave light, the surround is reflecting a lot less middle wave light because it's less efficient for reflecting middle wave light. And there's a ratio in the amount of middle wave light reflected from this green surface and from its surrounds. And similarly, there's a ratio for the amount of long wave light reflected from this green surface and from its surrounds, and the amount of a ratio for the amount of shortwave light reflected from this green surface and from its surrounds. These ratios never change because these surfaces have reflectances that never change. By reflectance, I mean the amount of light reflected from a surface as a function of, as a percentage of the amount of light incident on it. A surface may reflect, say, 75% of middle wave light, regardless of what the actual amount is. And since all surfaces have got fixed reflectances, the ratios themselves, which the brain undertakes, never changes. And it is through this ratio-taking process that the brain is able to construct a color, as I describe in this lecture. Now, this ratio-taking process, critical to it, is a part of the brain which is known as V4, and damage to V4 leads to the syndrome of cerebral achromatopsia, in other words, an incapacity to see the world in color, and therefore an incapacity to be able to obtain knowledge about the world of color, and therefore an incapacity to stabilize the world in terms of color.